This is RD Sharma's solution, class 12, chapter 12, higher order derivatives, MCQ, multiple choice questions we are taking. If we have x is equal to a cos nt minus b sin nt, then d2x by dt square we have to find out. So there are four options, one will be correct, and these kind of questions we have already did. So let us do it. It's simply just a differentiation, but there is no dy by dx here. It's actually d2x by dt square. So x is equal to a cos nt minus b sin nt dx by dt. A cos nt is minus sin nt. Then the differentiation of nt will be n. Minus b sin t will be cos nt. Differentiation of nt will be n. This is dx by dt. So d2x by dt square. So minus a, so minus an was already there, sin nt is cos nt, so there will be again an n, so n square will be there. Here we have cos nt will give you minus sin nt, so I have made this negative as plus, again cos nt, sin nt, then n will come, so we have bn square. Okay, I am taking negative outside here because I need this a cos nt minus b sin nt somewhere. So if I take minus n square outside, it will be a cos nt, and here if you take this already we have taken outside n square, so it will be b sin nt. So what is this? As I said, when you take minus n square, the inside thing will be nothing but x. So d2x by dt square is nothing but negative n square x. This is how you are going to write actually. So these wordings also to be followed. X is equal to at square, y is equal to 2at, then d2y by dx2 we have to compute. So we have just completed this in previous discussion, but we'll try to do it again. X is equal to at square, dx by dt is equal to a, so t square will be 2t, so 2at. Y is equal to 2at, dy by dt is equal to 2a only. We need dy by dx, so dy by dx is nothing but dy by dt divided by dx by dt. So just divide these two. 2a by 2at is 1 by t. So this is 1 by t, but this is just dy by dx. We have to compute d2y by dx2, so you have to differentiate this again. 1 by t is going to be equal to negative 1 by t square. You know already about this differentiation. But we are not going to stop here because we are differentiating with respect to x, not with respect to t. So you have to introduce dt by dx also. Dx by dt is already with us, so we have the reciprocal of 2at and multiply minus 1 by t square into 1 by 2at. So this t and t square will give you t cube minus 1 by 2at cube. This is the option you are going to choose for d2y by dx2. Four options, one will be correct. Y is equal to a x to the power n plus 1 plus b x to the power minus n, then x square into d2y by dx2. This question in 12.2 exercise of higher order derivative have already been done, but for the sake of completion, let us do it quickly. Y is equal to a x to the power n plus 1 plus b x to the power minus n. dy by dx is equal to a. See, x to the power n differentiation is nx to the power n minus 1, so you have to follow it wherever x is there. So it will be n plus 1 x to the power n plus 1 minus 1. So this will be x to the power n only. Now you know already that negative is going to come, so I am just putting it negative here. B, this x to the power minus 1 is minus n x to the power minus n minus 1. So negative has already come. So this is just dy by dx. We are going to compute d2y by dx2. So d2y by dx2 is going to be a n plus 1, and this already I showed you, it is nx to the power n minus 1. Now minus b n, this comes in front, so minus n plus 1, and minus n minus 1 minus 1, so minus n minus 2 it will be. So this what you can do is a n plus 1 x to the power n minus 1, and then minus b minus I am taking just outside, so I am making it plus b n plus 1 x to the power minus n minus 2. So d2y by dx2 you have to multiply it by x square, so just multiply it by x square. So x, the power can be added 2 and n plus n minus 1, you have to add 2 plus n minus 1 is simply n plus 1. So you have a, see, n plus 1. So we already have ax to the power n plus 1 in y. So we actually are eyeing upon getting y again. So what I am trying to do here is, we know that ax to the power n plus 1 is already there. So whatever is left, just take it outside, right? Just take it outside. Here also, you have to add this 2 plus minus n minus 2. So you have x to the power minus n, which was with b when we started with y. Now n plus 1 you can take just outside, and whatever is inside just write it ax to the power n plus 1 and plus bx to the power minus n, and this is nothing but y only. So you get n plus 1 into y. This is your x square into d2y by dx2. This is your answer, n plus 1 into y. So there may be some misprinting, but you know how to get the answer. Okay, if you want to do it directly, this kind of question, it's d raised 20 or d20 by dx20. So you have to differentiate it 20 times. Well, that won't be possible for us to do. It is possible, nothing is impossible, but there has to be some trick. What is the trick here? The trigonometric identity and equation will come handy in this. First, this 2 cos x cos 3x. So 2 cos a cos b is nothing but cos b minus a plus cos b plus a. This you already know. Alright. So just remember, cos a minus b plus cos a plus b is nothing but 2 cos a cos b. So that is what we are going to apply here. 2 cos x cos 3x can be written as cos 3x minus x plus cos 3x plus x. So the multiplication thing we have converted it into the addition thing. So we will take it to 1, 2, 3 level, and then we'll try to find out a pattern, and depending upon or according to that pattern, we can finally get the final solution, general solution you can say. So cos 3x minus x is cos 2x, cos 3x plus 4 is cos 4x. So we are differentiating it. Cos 2x is minus sin 2x, and we have 2x differentiation is 2. Here also cos 4x is minus sin 4x, then you have a 4. So just taking minus here. Okay. Now just take minus 2 outside. So this is the odd differentiation, first differentiation. So minus 2 I have taken out, and then sin 2x plus 2 sin 4x, then d2y by dx2. This is the even differentiation, d2y by dx2. So minus 2 was already outside, sin 2x was cos 2x, 2 will also come here because differentiation is 2x is 2. Then sin 4x is cos 4x, then differentiation of 4x is 4. Now just take 2 again outside. So you have minus 2 here, 2 taken out. What is inside? Cos 2x plus 4 cos 4x. Now this is an even differentiation. Now remember that d20 by dx20 is an even differentiation. So this is going to come. We just need to know what this 2 square or something will come. So we have written this as minus 2 square, and inside also we have done the 4 has written as 2 square. So now again differentiating, cos 2x is minus sin 2x, 2 will come in front, then plus this 2 square. I'm taking minus because cos is minus sin 4x, and then 4 will also come. So this minus 2 square is already outside. Now take this negative outside. This is a odd differentiation. d3 y by dx3 is an odd differentiation. So minus 2 cube. Now you are able to see the pattern now. Okay. So 2 cube. Then we have 2 sin 2x. This 2 we have taken outside. So only 2 will remain. So it will be 2 cube sin 4x. So I'm not doing d4y by dx4, since already we know the even and odd differentiation has given us a proper pattern here. Alright. So just do one more differentiation if you want, just to give an idea to the examiner that you know what and how to get the pattern out of it. This is the first differentiation. This is the second differentiation, and we need the second and fourth differentiation to draw the pattern. The third one was this one. So you just have to take the second differentiation or fourth differentiation and just see what is the power. Alright. So whenever we're differentiating, when we have d3y by dx3, it is minus 2 cube or 2 cube to be more precise. And inside also on the second term we have 2 cube. So when we do d raised 20 by dx20, it will be 2 to the power 20, and the even was d2y by dx2. What was there? It was cos 2x plus cos 4x inside. Alright. So this cos 2 to the power 20, cos 2x plus 2 to the power 20, right? 2 to the power 20. So this is the answer. Your second option is correct. This is just a pattern kind of question, but the trigonometric identity is very important. Now, x is t square, y is equal to t cube, dx by dt is equal to 2t, dy by dt is equal to 3t square. Now, dy by dx is nothing but dy by dt divided by dx by dt. So take dy by dt, divide it with dx by dt, you will get 3t by 2. So you will be tempted that, oh, fourth option is correct and we have got the answer. No, d2y by dx2 has to be done. So 3 by 2. Now dt by dx, because t is there, so dt by dx also has to be there, dt by dx. So d2y by dx2, 3 by 2 dt by dx, and dt by dx is nothing but the reciprocal of dx by dt. Dx by dt is 2t. So 3 by 2 into 1 by 2t, this is 3 by 4t. This is your d2y by dx2. This is your answer. The B option is correct. Y is equal to a plus bx square. So there are 4 equations. Which equation you are going to get? Just differentiate and try to get y equals to a plus bx square, or say y1 or y or y1, wherever it is possible. So y is equal to a plus bx square. Dy by dx is simply, you can write it as y prime or y1. So dy by dx is a 0 because it is a constant. B x square is 2x. So you get 2bx. Dy by dx is 2bx. Then we have this, you can call it as y1 or y1 y prime. So y2 d2 y by dx2 y prime is 2b. Now y double prime y2 is 2b. Let us multiply both sides by x, because we know that y1 is nothing but 2bx. So we are multiplying both sides by x. So x into y2 is equal to 2bx. It is y1 only. So x y2 is equal to y1. So you can write it as x d2y by dx2 is equal to y1. Alright. So this is your option. You can just choose this option here. Okay, this question is a complex number question. It is a complex question actually if you are aware of de Moivre theorem, because it is cos x plus I sin x. Cos x plus I sin x is a relation or an equation which says that since we have a I there, that means it is a complex equation. So if you are not aware of de Moivre equation or theorem, it will be difficult for you to attempt this. So for that, to make it easier for you, I am showing you de Moivre theorem. So z equal to r cos theta plus I sin theta. When we do z to the power n, it will be r to the power n cos theta plus I sin theta to the power n. Alright. So this n will come with theta. That is z to the power n, r to the power n. Cos theta plus I sin theta will be to the power n, the n will come with theta. Now question is also saying f1 is 1 and f double dash 1 we have to compute. So this is the reference, because if those who have understood to apply the de Moivre's theorem, you can just go ahead and we will start with the solution. Fx, I'm just writing it in short. Fx is cos theta plus I sin theta, and then we have cos 2x plus I sin 2x, theta x we are interchangeably using, and the last one will be cos x plus I sin x. So since we know this cos 2x plus I sin 2x by de Moivre theorem can be taken as the power of cos theta plus I sin theta. Essentially all will be cos theta plus I sin theta with the power which is there with theta, or in front of theta, or in front of x in this case. So cos x plus I sin x, this can be written as cos x plus I sin x to the power 2. This goes up to cos x plus I sin x to the power n. This is de Moivre theorem. So these bases are all same. So we can add the powers. 1 plus 2 plus 3 plus till n. So cos plus I sin and to the power 1 plus 2 till n, and 1 plus 2 plus 3 plus n is nothing but n plus 1 by 2. You know already that this is an arithmetic progression equation, and we already know this is n plus 1 by 2. So what do we get? Cos x plus I sin x to the power n plus 1 by 2. Let us write it as, say, a. So we are writing it as a. A is n plus 1 by 2. So this is essentially equal to cos ax plus I sin x, because by de Moivre theorem this goes in front of theta. So here we have x. So we have this a goes in front of theta. F1 is what? Cos a plus I sin a. Remember, F1 is equal to 1 here. F1 is 1 here. So cos a plus I sin a is equal to 1. And this has to be kept in mind because we are going to use it in a short while. F dash x now differentiated. Cos ax is minus sin ax plus I sin ax is cos ax, and both the terms this ax differentiation will come. So we have minus a sin ax minus I cos ax into a. So you can take this a as outside. A was already outside, so we are taking a outside. So this is going to be a minus a sin x. This is f dash x only. In f double dash x, then you will get one more differentiation. So f double dash x, a here you have sin ax will be cos ax with a negative sign. Cos ax will be minus sign ax, and then again a will come. I will be there. So we have this a taking outside, a square minus a square you take, and a, remember, it is n plus 1 by 2, nothing else. Cos ax plus I sin ax it is. This is f double dash x. Now this f double dash x, we have to compute f double dash 1. The question is asking about f double dash 1. And we already have minus a square cos ax plus I sin ax. So in place of a square, I am replacing a by n plus 1 by 2, because a was n plus 1 by 2 only. So we have minus n plus 1 by 2 cos a plus I sin a. But when you put 1 in place of cos a plus I sin a, we have already seen that it is f1. f1 was cos a plus I sin a, and it was essentially equal to 1. So this second term, a cos a plus I sin a, is nothing but 1 from the equation 2 in this case, if you see to the left. Alright. So f double dash 1 is nothing but minus n plus 1 by 2 whole square into cos a plus I sin a. Cos a plus I sin a is 1. So you are just left with minus n plus 1 by 2 whole square. F double dash 1 is n plus 1 by 2 whole square. So now there are certain options in your answer, and you can choose the option as minus n plus 1 by 2 whole square. Please remember, this first differentiation result is used here because cos a plus I sin a was 1. We have already computed and we utilized it in the f double dash 1. So this we are going to take in the next discussion. Till then, thank you so much and take care of yourself.